1,000. This time we're going to use the z-score. This is the best way to do this one. 1,000 minus 1252 over 129. Which is negative 1.95. And you can put that in the calculator, but I think it's actually faster to go back in the chart. Go back to table 5 and look up negative 1.95. So there's negative 1.9. And then over 0, 1, 2, 3, 4, 5. And so that number, which is 0.0256, which is about 2.56%, which rounds off to 3%, and that corresponds to the third percentile. Whoops. So we look up the z-score, or calculate the z-score, look up the z-score, round that off to the nearest percentage, and that will give you the percentile. So third percentile. That one's kind of tricky. I don't think that one's on the final. All right, let's keep going. Next one is from chapter 8. Question number 26. Let's see. Number 26. According to a study conducted by a statistical organization, the proportion of Americans who are satisfied with the way things are going in their lives is 0.82. These problems are so silly. All right, so our P is 0.82, our percentage. Suppose that a random sample of 100 Americans is obtained. Complete parts A through C. So part A, describe the sampling distribution for the sample P hat. So for describe, we need shape, center, and spread. The shape, we have to check if n times p times 1 minus p is greater than or equal to 10. So our n is 100, our p is 0.82, and then 1 minus 0.82. We need to see what that comes up with. So 100 times 0.82 times 1 minus 0.82. Just type all that in. As long as whatever that spits out is greater than 10, we can say that the shape is approximately normal. The center is always going to match the percentage they give you, 0.82. And the spread, I always have to go back to the chart, make sure I don't screw this up. The spread will look like that, the standard deviation. So it's the square root of p times 1 minus p over n, which is the square root of 0.82. Now I can do 1 minus 0.82 in my head and get 0.18. Otherwise you can just type that in to get 0.18. It just saves you a little bit of typing if you can actually just crunch that number over 100. So square root of 0.82 times 0.18 over 100. You get 0.038. So we'll choose that answer. And then part B. Using the distribution from part A, what is the probability that at least 80 Americans in the sample are satisfied with their lives? At least 80, which is greater than or equal to 80. Now we have to convert that into a p-hat value, which is 80 over 100, which is 0.8. So at least 80, which is 80 or more. We're going to use normal CDF, since we now know that the shape is approximately normal. We can use normal CDF. Our lower bound is going to be 0.8. Our upper bound is going to be infinity. Our mean is 0.82, which is the center, and our standard deviation is 0.038. I'm going to go ahead and put the 4 on there just for precision. You want to be as precise as possible. 4 decimal places is the expectation. If you round too much, your answer will be thrown way off. So I'm going to do a normal CDF. Put in those values, 0.8, positive infinity, 0.82, and 0.0384. I get 0.698, round that off to 8. 0.6988. And then part C. It says, find the probability that 79 or fewer, 79 or fewer, which is less than or equal to 79. Again, we have to convert that to a decimal. I'm dividing by 100 because that's my sample size, 100. That's 0.79. So it says or fewer. So this time my lower bound is negative infinity. My upper bound is 0.79. My mean is still the same, 0.82, and my standard deviation is still the same, 0.0384. Run that, normal CDF, negative infinity, stupid glare, 0.79, 0.82, and 4 digits for the standard deviation gives you 0.2173. And that's it. So the first part to me is the hardest, and then part B and part C function just like chapter 7. The only thing a lot of students forget is to convert it into a proportion because the initial number was a proportion. So if the initial value they give you is a percentage or a decimal, make sure that the numbers you're putting into normal CDF are also decimals or ratios. So that's the only thing students get caught up on those kind of questions. All right, next question. Let's see. The next one looks like it comes from chapter 9. This is question number 27. Let's see. So it's determine the point estimate of the population proportion, the margin of error, and the number of individuals in the sample with the specified characteristic. So it's giving you a confidence interval, 0.172 to 0.768. The point estimate is going to be exactly in the middle between those two values. So to find exactly in the middle, we're going to average them. 0.768 plus, 0.172, so you add them together and then divide that by 2. That will tell you exactly in between those two numbers, which is 0.47. To find the margin of error, you subtract the answer we just got from, I always use the upper bound. You can use the upper or the lower bound, it doesn't really matter. But I do 0.768. I always take the upper bound and subtract the point estimate. We're trying to find the distance between the bound and the middle. So I always use the bigger number so that my answer is positive. But the margin of error is positive and negative, but it's that number. You do the same thing by taking the lower bound and subtracting the middle. You'll get the same number but negative, and really just the value is what we're looking for, 0.298. That is your margin of error. And then the number of individuals in the sample with a specified characteristic. Our sample size is 1,000. We're going to take our point estimate and multiply that by our sample size. So we're taking our predicted point estimate, or that's not predicted, that's the sample point estimate, multiplied by the sample, I believe that's 470. 470. So that means that 470 people in our sample had the characteristic, and that's how we got 0.47. So you just multiply it by the sample size. Sounds tricky, but it's not. So again, to find the middle, you average. To find the margin of error, you subtract. To find the amount in the sample, you just multiply. Not too bad. All right, let's see. Next question. Also from chapter 9, question number 28. Okay, this one's a little trickier. This is finding sample size, and you can find these formulas in your formula booklets. It says a researcher wishes to estimate the percentage of adults who support abolishing the penny. What sample size should be obtained if he wishes to estimate the estimate to be within 4 percentage points with 95% confidence? And it says if he uses a previous estimate of 28%, so we'll use that formula first. And then the second part does not use any prior estimates. We'll use the second formula. So we write that first formula down. N equals p hat times 1 minus p hat times z of alpha over 2 over e squared. Now e has to be a decimal, a percentage as a decimal. And same thing here, the p and the p hat need to be decimals. Z of alpha over 2 we'll also have to look up. So it tells us that our previous estimate is 28%, so that's 0.28 times 1 minus 0.28. And then Z of alpha over 2 depends on the confidence level. So that number comes from 95% confidence. We're going to look that up in the back on the last couple pages. That little chart at the bottom gives it the critical value. So 95% is a 1.96 for a critical value. So that's 1.96. And now E is 4%, but we're going to use 0.04. Always convert your percentages to decimals and then squared. So I think if we're careful, we can type all this in at the same time. The calculator will follow the order of operations, and we always have to round up. So that's going to actually be 485. And then part B is similar, except instead of using 28%, we're going to use the empty percentage, which is 0.5. And the chart has already taken care of that part for you. If you review my Chapter 9 videos, you'll see that the 0.25 has already been taken care of. So it's 0.25 times the same critical value, because it's the same level of confidence, so it's still 1.96, over the same margin of error, 0.04 squared. And that will give you a different sample size. Let's see. 0.25 times 1.96 over 0.04. Whoops. Squared. Sorry about the glare. 600.25. So again, we have to round up, so it'll be 601. So that's finding sample size, which I explained in my Chapter 9 videos. All right, your next question comes from Chapter 9, Section 2. This is question number 29. Says a poll was conducted that asked 1,018 people. So as I read the question, I always write down the important information. 1,018 people, how many books they have read in the past year. Results indicate that a sample average was 11.4, and a sample standard deviation was 16.6. construct a 95% confidence interval for the mean number of books people read. So we don't have to set this up, we just want the confidence interval. So if you go to stat and then tests in the calculator, you'll find one that says t interval. Stat over to test, down to option 8. It says t interval. And it will just ask you for the information. So 11.4 was the X bar, standard deviation is 16.6, sample size 1018, and confidence level. So you just put in all the information they ask. Confidence level needs to be as a percentage, as a decimal, and then down to calculate. It always takes it a minute, and then it will give you your interval. It says to round to 2 decimal places, so we'll do that when we type in the answer. First number would be 10.38, and the second number would be 12.42. And that's it. So if it just wants you to spit out the confidence interval, you can use the intervals in the calculator to help you do that. All right, next question. Number 30. Let me pull it up. All right, this is where we're going to find sample size. Doctor wants to estimate the cholesterol. How many subjects are needed to estimate the mean? Within 2 points, with 99% confidence. Assuming that the previous standard deviation was 18.3. So for 99% confidence. So again, we're going to use what they gave us here to estimate it for a population mean. So I'm going to write that down. N equals Z times S over E, the whole thing squared. So Z, we're going to use 99% confidence. So I'm going to look that up on that last page, table 5, or the second to last page. Here in the bottom little corner, whoops, 99%. I know that's hard to see. It's 2.575. So we will use 2.575 for Z. S, they told us, was 18.3. And for means, you don't have to change this. It's not a percentage, it's just 2. So it's 2.575 times 18.3, all divided by 2, and then the whole thing squared. So if you type this in with proper parentheses, it should work out, and then we round up 556. So just use the formula chart in the calculator so that you don't have to worry about working it all by hand. And then for 90% confidence, we're just going to look in the chart. Whoops. There's 90%, 1.645 for the critical value. So we're just going to change that one part. So instead of 2.575, this time it's 1.645. Everything else stays the same. The whole thing is squared. I like to use second enter, so if you push second enter, you can just change that to 1.645 by writing over it. And we're going to round up again to 27. So use the formula chart and the calculator. And decreasing confidence level decreases the sample size needed. If you want to be less confident, you don't need as many in your sample. All right. And looks like we have one more or two more. Let's see. So this is question number 33. pull it up here. It says test the hypothesis using the classical approach and the p-value approach. So I'll show you both. The null hypothesis is that whatever we're referring to is equal to 40% or 0.4. So that's the claim that we're trying to, that's kind of the innocent 40%. And the alternative is above 40%. So we're trying to show that whatever we're talking about is above 40% instead of just equal to 40%. And then our sample size is 250. The number that we got was 115, and our significance level is 0.01. So the classical approach is when we use the z-score to help us out. And if you go to chapter 10, there's how to get the z-score for proportions. We're talking about percentages here, so that's how to get the z-score. So z would be the sample proportion we got. Now we're going to have to get that ourselves. P hat is 115 over 250, which is 0.46. So we got 0.46 minus the null or the starting value, which is 0.4. That's what we're testing against. Over, and then we're going to have to calculate the standard deviation down here. It's kind of a mess. 0.4 times 0.6 over, and I got 0.6 from doing 1 minus 0.4. I always do that part in my head, but you can always just subtract over my sample size of 250. Now if you do this right, you can type all that in at the same time. So 0.46 minus 0.4, I'm going to put that in parentheses, divided by the square root, 0.4 times 0.6 over 250. So if you just put the top part in parentheses and the bottom part in parentheses, you'll get a z-score of 1.936. And then we need to look up the critical value for 0.01. So we're going to do inverse normal of 0.01. It's under second bars. Or you can look it up in the chart. That would be negative 2.326. And the negative doesn't really matter. If the z-score is smaller than your critical value, you're in the safe zone. So again, if you look at the bell curve, explain this quickly. This is the 0 mark. This is the mean. This is 1, 2, or 3 standard deviations above, negative 1, negative 2, negative 3 standard deviations below. So our value was right here. And the cutoff point, you don't need to worry about the negative, was 2.3 up here. So anything beyond that would be too extreme. Ooh, you can't see. Anything beyond that is too extreme. Anything less than that is not that extreme. So our sample was not as extreme as a 1% significance level. So we would fail to reject. So we do not reject the null hypothesis because the test statistic is less than the critical value. Now the other way is the p-value approach. And for the p-value approach, I would just let the calculator do this by going to 1 prop z test. And you can find the directions for that at the end of chapter 10 in the textbook. After the assignments, you can see how to put this in the calculator. But you're going to go to stat tests, 1 prop z test. The p naught is your null, 0.4. Your x is 115. Your n is 250. and we're testing the greater than. So you just put in the requested values, hit calculate. It gives you that z-score, 1.936, which is what we got. It also gives you the p-value, 0.0264. And this is another way to confirm this percentage is larger than your alpha level of 0.01. So since it's greater than 0.01, that means it's not as extreme. That means it's not extreme. And if it's not extreme, you do not reject. So the p-value is greater than alpha, which means it's not extreme, so we do not reject. All right, I'm going to pause there. I think you sent me a couple more, but I'm going to pause and then I'll continue recording in just a minute.